Hello everyone, this is lab session number 4. So today we're going to study a new type of circuit that can be used by using the op-amps. So far we study the three types of basics op-amp circuits, such as non-inverting type, inverting type, and unity gain op-amps. And also we studied how to build integrator, how to build differentiator, and also how to build pass filters like low pass, high pass filters using the op-amps. So now we're gonna study something interesting, something different. So before we use the signal generator or function generator to generate the sinusoidal wave or triangle wave or the square wave. But imagine if the situation you wanna build a circuit, then when you wanna use the, for example, as input the square wave or the triangle wave, but you don't want to bring every time this heavy, big expensive oscilloscope with the signal generator. So actually what we can do, we can build this signal generator by just using the two op-amps, and it's going to be actually cheaper than using this expensive one. We just need to use two op-amps together, which can actually give us the triangle waveform, for example. So let's start. So as we know before, when we study integrator, we know if we input the square signal, integrator gonna integrate it, and it's gonna give us the triangle wave. So in order to get triangle wave, we have to just convert the square wave by integrator. So how to make integrator we already know. So how to make actually the square wave without using the signal generator. So it's actually pretty easy. There is a special type of the op-amp circuit that can be used to produce the square wave. It's called the Astable Multivibrator. Basically, what is a stable multivibrator? A stable multivibrator can be look like this. Basically, it has two feedback resistors, two minus, two inverting input, and another resistor to non-inverting input, and it has two inputs connected, one negative inverting input connected to the capacitor, and capacitor connects to the ground, and the non-inverting input is connected to resistor, which also is connected to ground. As we can see here, we don't have any input signals. All the circuit can work just using the biasing DC voltage. So in our case, in this situation, we're gonna use just 10 volt. So set up your power supply to 10 volt, as previously here, and connect the Astable Multivibrator like this. Connect to feedback resistors, one resistor to plus and one capacitor to minus. And by biasing this circuit, we should get an output square wave. Let's see. So I already prepared the connections. Basically, we have two feedback resistors. So to the plus, we have to choose for the plus the 1K resistor, and choose the biggest resistor for the input. So this plus, we choose 1K resistor here, and the biggest resistor that we choose here is 10K. So two resistors here to the plus, one goes to the ground, 10K goes to the ground, and 1K goes to the feedback loop, 1K goes to the output. This is a plus connection. For the minus connection, choose the biggest capacitor we can choose here is 10K. So we have feedback loop of 10K resistor goes to out, from the minus to out. As is written here, minus goes resistor, and another resistor goes here. So it's 10K, 1K. It should be also 10K, but since we have limitation of resistors here, so we're gonna choose 1K. 1K, 2K, this is a 10K, and also you have to connect the capacitor to the negative input. So we have the small, so in this case you choose the smallest capacitor that goes to minus and then goes to ground. So both plus and minus eventually goes to the ground. And output connect to the oscilloscope. So let's see, let's turn on the power supply. And as we can see here, this Astable Multivibrator can produce the perfect square wave signal. So the power supply is 10 volts, and output we're having the 8.4 voltage peak-to-peak square wave. As remember, we should have some room of the signal, so we don't get 10 volts, we're gonna get less than biasing. So there is some room of 1.6 voltage actually. But if we're gonna increase 10, let's say to the 20 or 15, let's go to 15. we should expect increase of the output. So by changing the biasing, we can actually increase the output voltage of the output signal. But let's keep it for 10. So this is how the Astable Multivibrator is working. Now once we build the Astable Multivibrator that can produce a square wave for us, now let's connect the output of this Astable Multivibrator to the next stage, which is integrator. Integrator we already know. Integrator is just simply the circuit, the op-amp, when we connect this capacitor to the feedback line and to the minus, and minus goes to the resistor and plus goes to the ground. So connect the plus to the ground, gray wire goes to ground. Minus, in the minus we should connect capacitor as a feedback look. Choose the smallest capacitor you can find here, smallest capacitor, so it goes to minus and back to the out, so it's feedback capacitor. And input resistor is, choose the biggest resistor you can find, the 10K. So this 10K goes to the minus and goes to the output actually of the Astable multivibrator. So the output of Astable multivibrator that produce the square wave goes to the input of the 10K resistor that goes to the minus of integrator, as seen here. So once we connect everything, so one more time, this 10K resistor, there is smallest capacitor, is 0.1 microfarad, and the plus goes to the ground. So let's turn on the biasing, and as we can see, we are having the triangle signal as we wanted. So we just created the triangle wave generator. Only the discrepancy we can see here is actually the clipping or cropping of the top peak of the triangle, but it's fine. The reason is why it's happening is just because we have limited number of resistors here. So basically in the integrator it's better to use the biggest resistor we can find in the range of 100 kilo ohm, but since we have only the 10 kilo ohm, this is what we can do. But still we can have like produce the triangle square wave just using those two op-amps. So now that's it. So try to repeat the same circuit and try to generate first by making the Astable multivibrator generate the square wave waveform, and then by attaching the integrator generate the triangle wave. That's it. Repeat and try to actually choose different resistor and see how actually the frequency changes. So the task for this swap actually see how you can actually change the frequency of this triangle wave. First, the frequency of the square wave, what kind of resistors can affect the frequency of this signal, and also what kind of resistor and capacitors can affect the frequency of output of triangle waveform. Record everything and write the report, and also do the simulations and compare the simulation with experimental results.